Hello students. So far we have seen how to check the symmetry of the given curve with the x-axis and the y-axis. We have seen that the given curve can be symmetric about the x-axis or y-axis or both the x and the y-axis. But at times the curve isn't symmetric with both the axes, that is either x or y or both the x and y. In such case, how to proceed? Then we have to check the following points. We have to check the symmetry of the curve in opposite quadrants. How to check it? It said a curve is symmetrical in opposite quadrants if its equation remains unchanged, if x and y are changed to minus x and minus y simultaneously. That means, suppose you have this equation of the curve, which we are going to see. Y is equal to x cube. You are going to replace y with minus y and x with minus x simultaneously. And if the equation remains unchanged, we can say that the curve is symmetric in opposite quadrants. The next one, symmetry about the line y is equal to x. If the equation of the curve remains unchanged, if x is changed to y and y is changed to x, then the curve is symmetrical about the line y is equal to x. We can see here the equation of the curve is xy is equal to c square. If we replace x by y and y by x, there is no change in the equation of the curve. The equation remains unchanged. Hence we can say that the given curve is symmetric about the line y is equal to x. You can see this in the figure. And the last one, symmetry about the line y is equal to minus x. If the equation of the curve remains unchanged, if x is changed to minus y and y to minus x, then the curve is said to be symmetrical about the line y is equal to minus x. That is, in the given equation of the curve, we have to replace x by minus y and y by minus x. And then if the equation of the curve remains unchanged, we can say that the curve is symmetric about the line y is equal to minus x. Now, we'll see an example. The equation of the curve is given as y is equal to x cube. Now, symmetry. Now, we can see here there are no terms in x and y with even powers. The power of y is 1 and that of x is 3. So, the given curve, it is not symmetric about either the x-axis or the y-axis. Now, if we replace y by minus y and x by minus x, then what will be the equation? So it will be y is equal to x cube. So it will be minus y is equal to minus x whole cube. That is minus y is equal to minus x cube or y is equal to x cube. That means the equation of the curve remains unchanged if we replace y by minus y and x by minus x. That means the given curve is symmetric in opposite quadrants. Next comes the intersection of the curve with the origin and the coordinate axis. First, the origin. We'll put x is equal to 0 and y is equal to 0 in the given equation. So what we have is y is x cube, that is 0 is equal to 0. Hence we can say that the given curve passes through the origin. Now the x-axis. For that we'll put y is equal to 0 in the given equation. So we have 0 is equal to x cube, which implies x is equal to 0. That means the curve intersects the x-axis at 0, 0, that is the origin. there is no other point where the curve intersects the x-axis. Then comes the y-axis. For that we'll put x is equal to 0 in the given equation. So we have y is equal to 0 cube, that is y is equal to 0. Hence again we can say that the given curve intersects the y-axis at 0, 0, that is origin. There is no other point where the curve intersects the y-axis. Now the tangent. First at the origin. We have y is equal to x cube. Lowest degree term here in this equation is y. We'll equate it to 0. So what we have is y is equal to 0. That means x-axis, because y is equal to 0 is the equation of x-axis. So we can say that x-axis is a tangent to the curve at origin. Then comes the asymptote. First, parallel to x-axis. Now coefficient of the highest degree term in x. The equation is y is equal to x cube. So the coefficient of the highest degree term in x, it is 1. Equating 1 to 0, which doesn't make any meaning. So we can say there is no asymptote which is parallel to x-axis. Then asymptote parallel to y-axis. We'll equate the coefficient of highest degree term in y to 0. The coefficient is again 1, and equating it to 0, that is 1 is equal to 0, which is again meaningless. Hence there is no asymptote parallel to y-axis. Okay, then comes the region of absence. Now this is the equation of the curve. So what we'll do, we have these values of x. Suppose x is 0. What will be the value of y? It will be 0. If x is 1, y will be 1. Now if x is 1.5, we have the value of y as 3.4, and if x is 2, we have y as 8. Now the given curve, it is symmetric in opposite quadrants. Okay, so while plotting the curve, we'll draw the curve only with the positive values of x, and the remaining part of the curve can be plotted because the curve is symmetric in the opposite quadrants. So now if we see, we have when x is 0, y is 0. Okay, it will be this point. Then we have x is 1, y is 1. So if we take 1 here, this x as 1, we have y as 1, suppose here. Then what we have, x is 1.5, we have y 3.4. So if x is 1.5 approximately here, 3.4 will be somewhere here. So with the help of these points, we can trace the curve. So this is in the first quadrant, and the given curve, it is symmetric in opposite quadrants. So we can similarly trace the curve in the third quadrant. The curve is not present in second and fourth quadrant, and we have found out that at origin y is equal to 0, that is x-axis is a tangent to the curve at origin. This is the x-axis which is a tangent to the curve at origin. Thank you.